The function f has domain minus infinity to 0 and is defined by f of x equals x squared plus 3 all divided by x squared plus 5. A, part 1, show that f dashed is always negative. 2, write down the range of f. B, part 1, find an expression for the inverse of f. And 2, write down the range and domain of the inverse of f. So here's the question in summary form then. So let's differentiate to show the derivative is always negative. So here, f dashed x then is a quotient, so we need v, use the quotient rule, x squared plus 5, more than one term, put a bracket, times du dx, 2x plus 0, so that's 2x, minus u, more than one term, put a bracket, times dv dx, 2x plus 0, so it's just 2x, all over v squared, and that would be the v squared, so this object here, more than one term, put a bracket, squared. So that equals then, so we've got 2x cubed when we expand the bracket, plus 10x there, minus 2x times x squared is minus 2x cubed, and then 6x with a minus, so it's minus 6x, all over x squared plus 5 squared. So the 2x cubes cancel. We get 4x over that squared equals 4x over the x squared plus 5 squared. And here we can see that as x is positive, since x is negative on the domain, we see that 4x is less than 0 and x squared plus 5 squared is positive. So negative over positive is negative. F dashed x is less than 0 for all or for any x that's negative. So f of x, f dashed x is always negative then. Write down the range of f. So it's a negative gradient. It's defined on minus infinity to 0. And it's going downhill. So what is it at minus infinity really? Because it's going to go negative to 0. When it's 0 it's 3/5. So we've got a curve that's like, if we do a little sketch of it, say over here, it's only defined on minus infinity to 0. So back here, back that way of course. So it goes to, when x is 0, it's going to be 3/5, wasn't it? Yeah? 3 over 5 when x is 0. So it's here, say, 3/5. And then it's going to be a negative gradient, so it's going to basically come down in some manner from where it was at minus infinity. So if we look at it, what is it at minus infinity then? If we put minus, if we write that as divide by x squared top and bottom, it's 1 plus 3 over x squared, isn't it? Over 1 plus 5 over x squared. So as x gets large negative, this becomes positive, and this fraction here, 3 over a large positive, is small positive. Similarly with this, so it's going to tend towards 1 over 1, isn't it? And you can try that for various values. You could put x as 100, and that would be 10,000, so it's 1 plus 3 over 10,000 divided by 1 plus 5 over 10,000 is very, very close to 1, isn't it? 1 over 1, which is 1. So it looks like it's going to come down from the limit value at minus infinity, which is 1, down to 3/5. So we can now write down the range of f part 2. So the range of f then is equal to, it's going to vary from the lower value, which was 3/5, including 3/5 up to, but not including 1, because 1 was the limit value. Part B. So find f to the minus 1 of this function. So fx then, we can label it y equals x squared plus 3 over x squared plus 5. Let's move this object here up to the other side. X squared plus 5 times y equals x squared plus 3. And that tells us then that x squared y plus 5y is equal to x squared plus 3. So let's collect all the x squareds together then. So move this over here. Y minus 1, lots of x squareds, isn't it? When we move this over and collect the x squareds outside, is 3 minus 5y. And that tells us then that x squared is 3 minus 5y over y minus 1. And now square root both sides, and x equals. Now, what have we got here? I'm going to swap this fraction. Okay, I'm going to leave it as is then. So square root both sides, we get 3 minus 5y over y minus 1 square rooted. Now x, the domain values are negative, so when you square root this, it's going to be the negative solution we're interested in because the domain of x is negative. So now we've got that, we can write f minus 1 now of x. Change the symbols, this is y and this is x now. It's going to be square root of, with a minus, 3 minus 5x, isn't it? Over x minus 1. So there's our inverse function. Okay, so we've got the inverse. So let's just go back up. Write down the domain and range of f minus 1. Well, the domain of f minus 1 is equal to the range of f, which is equal to 3/5 up to 1, but not including 1, isn't it? And the range of f minus 1 is simply the domain of f, which is equal to minus infinity up to 0. I think that was the original domain, wasn't it? Minus infinity up to 0. Oh, it didn't include 0. So we'll need to tweak it slightly, won't we? Because if the 0 is not included, then the 3/5 has to be a round bracket here. So let's put that in a round bracket then. And then go down. And this would also be a round bracket here. Pen. Okay. And then the 0 is now a round bracket, of course, because that was the domain.